Welcome back to Cyber Prophets, the place where we prophesize the future of technology. A place that, as you know, is a podcast for you and only for you. Every week, we interview someone that can give you some insight about how the future will look like. And this time, we're bringing you Philipp Surrey, an expert in 3D printing. You might be thinking, what is 3D printing? Just a short reminder, they can print things like that in 3D. It can be plastic, it can be maybe a skull, something that comes to your mind. In our times, this is something very impactful and very important. He is working for John Deere, and he can tell us more about this important area. Tonight, Edgar is working with me as the co-host. Maybe he can give some extra words.
Hello, everyone. We are very glad to be here once again with you. And today we're going to talk about this interesting topic, 3D, which we think that will have a big impact in the future.
And what can I tell you? Philip is an expert in this area. 3D printing is something important, but he's going to focus on one important area that is sometimes not think so much, that is industrial 3D printing. But maybe Philip can tell us some words about himself and how he got started in this very innovative area.
Hello. First, thank you for inviting me to speak to you and the audience about 3D printing. I'm very excited to be here. It's the first time I'm speaking on a podcast, so I hope I do well. So I'm 20 years old, as you already mentioned. I'm working for John Deere. I'm living in Germany, in the southwest of Germany. And originally, I studied materials engineering in the west of Germany. And yeah, since my master program, I've been working on additive manufacturing or 3D printing. I was a research assistant. I was a researcher at the University of Hamburg. Worked there on additive manufacturing, 3D printing. And since 2018, I'm working for John Deere. John Deere is agriculture machinery manufacturer, and there I'm also working in the area of 3D printing.
Amazing, Philip. We're very glad that you accepted the invitation to our podcast. And you mentioned about that you studied materials engineering. What is that exactly?
In my studies, I learned about different materials, about their properties, about their characteristics, how to manufacture them, how to use them, and how to describe them, like describe the properties. And in that studies, like you learn about casting, you learn about forging, you learn about all those different manufacturing processes and the different materials you can work, and in one of them I learned also was 3D printing.
Oh yeah, so you think that it has helped you in your current job, like as 3D printer?
Yes, definitely. It was the first area where I got introduced to 3D printing. I, as a research assistant, as a student, my job was to describe, like I basically pulled them apart and measured how strong the materials are. Somebody else 3D printed, and then starting from there, I continued, like did my master thesis in the area of metal 3D printing, and then from there I just continued because it helped me to understand the influence of the process, the manufacturing process, and the material properties, so I could describe those.
Perfect.
And in these days, are you more involved in the designing part or operating the hardware or another area of 3D printing? Because there are multiple areas, I guess.
Yeah, that's true. As a student, as I mentioned, I actually operated hardware and machines. But honestly, it has been a long time. I operated some machine. In my current job at John Deere, I'm more of, I would say, technology scout. That is how I started. So I'm looking for new technologies, new processes. I evaluate them, see if they have worth for our company, how we can use them. Then I'm looking for new applications, trying to improve our internal processes. So I'm more of I would call myself a technical consultant for the company to explain my colleagues and everybody else, what is 3D printing and how can we use it.
So you're more like the innovator within the company.
Yes, you could say that. Trying to keep the eyes open for new things that we can use, and try to help people to adapt those and make the best of the opportunities we have.
Very nice, very nice. And can you tell me, please, Philip, what kind of applications does 3D printing have at an industrial level? Because we know, like as Federico mentioned, we know like at a basic level, what can we print? Something personal, let's say, but at an industrial level, what are the possible applications?
So the main groups, I would say, for applications of industrial 3D printing are rapid prototyping, rapid tooling, and rapid manufacturing. So what I work in a lot is rapid prototyping that we use in our development. The idea is there that you can very easily and quickly get first physical parts of the things you design, you want to create very fast and most of the times cheaper than you would do it in other ways. Rapid tooling would be that you produce the tools for some other processes like a forming tool, a casting, or some other tools you might need for manufacturing. And the third one, manufacturing, is that you 3D print the parts directly and, for example, sell them to a customer or something like that. And all of those you have in the beginning the rapid. So it's the idea is that you can do it faster than with other technologies. And that is because you don't need the tools. So 3D printing is one of the main characteristics is that you can manufacture something without the need of tools for manufacturing those. You can directly print it in a machine. With one machine, you can print different geometries. That makes it much faster because, for example, for a casting or for some other things, you have to take like weeks and weeks and sometimes even months until you get the tool, and then you can start manufacturing something. With 3D printing, we can directly start.
And for example, what kind of limitations have you noticed right now with the current 3D printed technologies?
So in the industrial area, of course, one of the biggest limitations is cost. 3D printing, depending on which process directly we're talking about, the cost is still considerably high. The machines are expensive, the materials are expensive. It's taking quite a long time to print something, which might sound paradox because I said before it's rapid prototyping. But yeah, like I said, it's rapid because we don't need the tool, but it's in itself, it's a slow process compared to others. That would be one of the biggest limitations, I would say. The other thing is size. We're still limited in the size. On the one hand, in the very big things, but also on the other hand, in the very small things. So there is some area where we can size-wise, like let's say like around like 30 centimeters, something like that. That is very nicely and doable. Very small things get very hard to 3D print because of the accuracy of the machines, and very big ones is also just very, very hard to do. And another thing where we have limitations are materials. There are quite a lot of materials that we can 3D print, but compared to other industrial manufacturing processes, it's very, very little. Let's say in choice, like there's steels, there's aluminiums, there's plastics, but only, let's say, a limited amount of possibilities that we have there.
And regarding the size, what is the biggest thing that can be printed?
So there has been 3D printing, for example, of a pedestrian bridge in Amsterdam, which is several meters wide out of steel. Then there has been a motorboat, for example, that has been printed
Wow.
out of plastic. And there's even houses that have been printed. So
Even houses.
so we can go up to meters and all the diameters.
Yes.
But like I said, that is only for specific processes. So something I want to explain is that when we talk about 3D printing or additive manufacturing, those
Yes.
can be used as the same thing, basically, just different names for the same thing, basically.
Mhm.
It is basically a group or a category of manufacturing technology. So there's not just one 3D printing process, there's very, very many of them. What they
Ah,
all have in common is that we are creating objects based on a digital 3D model, like I explained, without the need of tools. And
yes.
this normally happens layer upon layer, so one after another. And you can create objects like that. And how we create those layers and how we join those layers and what those layers are made of, this can be very, very different. Currently, there is, I would say, 5 or 6 major groups of ways to do that. We have material extrusion, we have powder fusion, we have photopolymerization, like a very, very different areas where or ways to join those materials together. And then within those, there's even more possibilities. So I would say there's about 15, 16 different technologies out there. Uh,
Wow.
and each of them
Yeah.
have limitations considering cost, material, size, and so on. So it's a very diverse and very dynamic area as well.
And what is the
Mm.
technology that you are most used to?
Um, I'm mostly working with currently mostly working with polymer-based processes.
Poly.
So we call it FDM, fused deposition modeling. This is also the technology that most people would know from their home printers or home 3D printers.
Mm.
That is what you can also get for your home. But in the industrial scale, those machines are just bigger and let's say more sophisticated, a little
Okay.
bit more robust and more accurate in what they do. That is something I work with almost every day. And then some other technologies. I wrote my master thesis in metal 3D printing, where we use
Metal. Wow.
powder as a basic material and melted with a laser. That is
Okay.
something I worked a long time. I would say 3 years as a scientist. So this is those two things. I would say those are my like the ones I'm most common or familiar with. But it's part of my job to know all of those. Let's say 15 different technologies.
Hmm.
And I'm wondering about something because based on everything that you said, how upgradable are the 3D printers? Maybe let's say the smaller scale might not be so much, but in the industrial 3D printers, for example, what if you get a new additive? Can you modify the 3D printer, or you need to buy a new one that includes the new additive to the product?
Hmm.
Most of them are pretty much I wouldn't say upgradable, but you can process a lot of different things with them. So with one FDM printer, you can produce or work with a lot of different polymers and materials. There are some limitations where you have like temperatures you need because most of the times we're melting the material in order to join it. So there's some limitations. In the industrial scale, it's not so common to upgrade them. Let's say, like the manufacturers, they offer some upgrades where you can add another feature maybe to achieve some new things you can do. But it's not as common as, for example, in the private sector where you basically can 3D print the parts for your own printer and advance it with that. We don't do that much in industrial size just because it's part of the, let's say, liability, of course, for the machines and stuff like that.
Yeah.
Um, but for example, a change between polymer and metals is not possible, just
Oh, okay.
because they're so fundamental different. Um, just to give you an explanation, one of the lower melting materials we have is aluminium, which
Yes.
melts around 660 degrees Celsius.
Mhm.
So in order to process that, I need a machine that can achieve that temperature. A plastic polymer 3D printer, we normally end at like 200, 300 degrees Celsius. So there's
Okay.
this big gap that you cannot melt. Like even if I put the material inside my polymer printer, nothing will happen with it because the temperature is just so far off. And that is for aluminium, which is one of the lower melting alloys. If we go to steel and more high performance alloys and materials, we're like in the 1,000 degrees Celsius.
Oh yeah, definitely.
So we can change between metal and polymer as we please. But within the polymer or within the metal, you can change a lot.
I see. I see. And now that we are like very specific about the process of fusing and melting, can you tell us specifically what is the process utilized to create a 3D printing? Let's say like from the conception of the idea until you have like the final tangible product.
Yeah. So we normally separate it in 3 steps. We call it pre-processing, the process itself, and post-processing. So pre-processing would be what you just said, like the concept or the idea of the thing you want to create. So you have to design something. And in 3D printing, we always start with a digital 3D model. So you have to use, for example, not for example, you definitely have to use a CAD, computer-aided design program to create the model in a digital space, just to have the form. You create the geometry of this, whatever it is. Let's say bottle, a bracket, or I don't know, can be anything. And as soon as you have that geometry in the digital space, you can use this information, this digital information, to create the machine code. So you use another software, most of the time it's another software, that you tell the machine what to do. Like the machine, the 3D printer has to know what it's supposed to do. And one of the very important things is that it slices the geometry in layers. So if you have a 3-dimensional object, it slices it in 2-dimensional objects. And in each layer, in each slice, again, the software creates a code that tells the machine what to do. And if you stack those informations on top of each other, the machine will create layer by layer the object. So this is still like the pre-processing, creating this information for the machine. As soon as you have that in the software, you send it over to the machine. That can be actually remote controlled. Like sometimes I'm starting a print when I'm not even in office. So, and from home office, it's possible too. So you send this information to the printer. Of course, it has to be in a, let's say, standby modus where it has the material already loaded and has to be in a functional operation mode. But as soon as it gets the information, it will start processing. Then you have this layer on layer creation. For example, with the FDM, fused deposition modeling, which you might know from home, is the print head moves around in a layer, then it goes down a layer, and then it moves again, printing down the material. In other processes, it might be spreading a layer of powder and then melting this powder with a laser. Or others could be dipping a platform into a liquid polymer and then again having a laser or light curing this material that it comes hard. So there's a very different things how this process can happen. And then when this is done, you take the part out of the printer. Some of the times you have to do some post-processing. That means you have to clean it, you have to remove some support structures you need for printing, or even just to finish it, let's say paint it, coat it, or do something else, and that is what we call post-processing. So it is creating the design, pre-processing, creating the information for the machine, then the machine does its thing, creating those layers on top of each other, and at the end you just finish it with some, let's say, conventional or traditional manufacturing processes.
Okay.
What kind of techniques do you know that are available in the market? Do you know that, well, I'm guessing that there are some that are more efficient and other that are less efficient, but
Hmm.
in everything there is a pros and a cons.
Yeah. So I've already mentioned some technologies there. The fused
Yes.
precision, which you know from
Mm-hmm.
home. Then one that is called selective laser sintering, which is for polymers, where
Mm-hmm.
we use polymer powder that is spread in a layer and a laser melting it.
Mm-hmm.
You have this process for also metals, where we call it selective laser melting, for example, where we use also powder metal, yeah, powdered metal that is melted by a laser. Um, I would say those are very common technologies. There is another group which we call direct energy deposition, where the powder or the material is not in a layer, but it's, let's say we have a nozzle that basically shoots the material into a laser or another heat source and melts it there
Wow.
to create the geometry. And one of the newer technologies that was invented or introduced, let's say, on an industrial scale from HP. It's called multi-jet fusion. It also works with the powder, polymer powder, which is melted in the process as well. So those are, I would say, some of them. But like I said, there's a lot of them, and I probably missed some of them right now out of the top of my head. But
Yeah.
I would say those are some of them.
Well, I have a follow-up question. When you mention powder, like what is this powder made of? Is it plastic? Is it metal, or what is it exactly?
So the powder can be a plastic polymer,
Okay.
plastic, but it
Okay.
also can be metal. That is both possible. We can process those, and those metals are very, very fine, right? They're the each individual particle is about 30 micron meters
Mm-hmm. Oh.
large in diameter.
Mm.
So there's very, very fine powders. You have to take a lot of care that you don't inhale those because it's a health risk.
Oh.
So people working
Okay.
on that is in a controlled environment or with masks and stuff like that, because the materials are very, very light. For example, for polymers, if you have so small things, they just go into the
Go in
air.
the air.
Yeah.
Yes.
So we have to take care of those. And metals, you have to take care that they don't, like they don't, they can explode in some of cases.
Wow.
So there is some health and
Oh my God.
secure safety issues, but those are under control. There are systems and procedures and processes to deal with those. As long as you know what you're dealing with, it's very
Yes.
easy to yeah, avoid the risks. But yeah, those are powders that are being used. Like I said, polymer or metal can be both.
Okay. Yeah. And another follow-up question. Well, since it looks like it can be like a dangerous job, and I didn't think about it before. I thought that it was like just modeling and then sending it to the printer. Never thought that it could be, it could represent a health risk. So I would like to ask you, what kind of measures are being followed in order to minimize these risks?
Um, yeah, I mean, if you're the designer, it's very like there's no risk. But as soon
Oh
as you
yeah.
have to go to the machine and work with the machine, operate the
Yes.
machines, there are some risks. I mean, of course, there is like the general safety culture that you have everywhere in the industrial space where you manufacture. So, um, protection clothes, personal protection equipment.
Hmm.
Then, like
Okay.
I said, the all the powder handling is tried to be minimized. Like so, the contact you might have as a person with the powder is minimized as much as possible. So there's a lot of automation going on, for example, sieving and recycling the powder that nowadays happens all automatically within the machine.
Mhm.
Then as soon as we get in direct contact with the powder, we're using breathing masks to be sure that we don't breathe in those. Those are special masks for this purposes, a little bit similar to the COVID-19 masks we all get to know
yeah.
now, but they're industrial grade, so they're a little bit better or finer meshes even, I would say.
Oh, nice.
Then we have controlled environments. That means the air, there's a constant air circulation. So
Yes.
that even if there is powder being emitted to the environment where the people work, this air is pumped out every now, like I don't know the exact numbers, but very often
Often.
in an hour we exchange the whole atmosphere, let's say in a room, just to be sure that there is nothing. There's filters everywhere, so we make sure that the contact with the powder is as small as possible.
Nice.
And I'm wondering, do you know how do they produce those powders? Because I know I'm like so concerned because it seems like even that part will be dangerous.
Yes.
Yeah, there's special industries for making the powders. Working with powders is nothing completely new and nothing specific for 3D printing. There's a whole industry which is called powder metallurgy,
Oh,
which
wow.
uses powders in numbers and amounts where additive manufacturing or 3D printing is just a very small percentage. So it is nothing very new. There's a lot of knowledge and experience with it already there. There is some differences, like very detailed. If you look very close, there are some differences, but generally speaking, processing, producing, and working with powders is for industrial scale. It's nothing very new or uncommon. Of course, there has been a learning curve. I've been part of that learning curve myself. Like when I started in, I would say 2015 with additive manufacturing, there was still a lot of question marks on how to work with those things and to take
Yeah.
care and stuff like that. There was a lot of development, but right now there is a lot of information there and out there, and we can use it. But for example, what I would not recommend to have a powder-based 3D printer at home.
At
I
home.
wouldn't recommend that. I know that there are some companies who sell it, but I wouldn't recommend it to do that. Stick with the things that use filaments or liquids and stuff like that. Those are very much safer to operate. As soon as you handle powders, yeah, there's some things you have to take care of.
That's a very great recommendation, and I'm pretty sure that our audience will appreciate it. Not to get a powder 3D printer for their homes. And you mentioned, Philip, and you kind of introduced it in a previous question, the concept of additive manufacturing. Is that exactly the same as 3D printing, or is there any difference?
There it is almost the same. Yes, it's almost the same synonym. It's more I would separate it between 3D printing is more like a common name that has been used a lot in a private sector.
Yes.
And additive manufacturing was introduced when the technology was moved or pushed to more industrial scale, and also with the intention to actually manufacture parts. Like the 3D printing or those concepts, they're out there for a long time. Like the first ideas and patents for 3D printing are, I think, from the 80s or something like that.
Yes.
But in this time it was strictly for prototyping. They didn't use it for anything else. It was only to do prototypes, to do mock-ups, and nothing else. But with time, the processes and the technologies, they matured and got more and more reliable. And then people started, hey, why don't I just manufacture things like for my customers directly?
Yeah.
And then more and more additive manufacturing was introduced as a word or
I see.
a concept, but it's basically the same as 3D printing. It's just this idea of creating objects layer on layer out of a digital model. So yeah, I would say it's the same, more,
Got it.
it's a little bit more who uses the words. And
Mhm.
3D printing is much easier to say than additive manufacturing.
True.
So I most of the time stick with 3D printing as well. It's just easier to articulate.
Yeah.
And for example, in the case of Edgar and I, we studied AutoCAD when we were, let's say, in high school. What kind of software do you use, or the people working in the 3D printed sector use more often?
So yeah, there's the I would say big major CAD software manufacturers or providers. You have your SolidWorks, you have your Autodesk Fusion, you have your CATIA or Creo. Those are like all just names of software packages you can use. Um, I hope I didn't forget anyone important here. And almost all of them nowadays also have some sort of additive manufacturing 3D printing
Oh, cool.
features. Some of them already come with some drivers for the 3D printers, some nice features or algorithms you can use. But it's still an area where there's a lot of development, a lot of things happen there. There's a lot of different software providers and ideas that are out there, because the beauty of the 3D printing is that you don't have many manufacturing restrictions. You have a very big geometry freedom in what you want to design. If you like, if
Yeah.
we're talking about, let's say, conventional manufacturing processes, you always have to have in mind, okay, I still have to somehow create a form out of it, a tool, or
Exactly.
there's a lot of limitations, what you can and what you can't do. With 3D printing, additive manufacturing, there are still limitations. There's not none, but it's much less. You can do much more cool things. And one of the things that we do is that we use it for bionic designs as well. So advanced designs and forms of geometry that you cannot produce in other ways, in other manufacturing processes. And those can be created by, it's so-called topology optimization. So you basically define the problem. It's mostly used for, let's say, structural, like mechanical problems, where you say, okay, I have the design space, I want the part to fit in this area, and I have a force here, and I have a force here, and I have something else like a restriction here. And then you let the algorithm figure out what is the best geometry to do that. What is the best topology for this part to do. At the end, you get a more or less usable geometry. It depends on what kind of software you use. You have to fix it a little bit and adjust it, but you can actually take this geometry and print it. Some
Yes.
years ago, you would take it and say, okay, how do I figure out, like, how do I make this now into a manufactural design? What do I have to like take away? What I have to add in order to make it manufactural? And nowadays with 3D printing, you can basically take it directly and print it. Like I said, in detail, there's some minor things you have to do. It's not that easy, but it's much easier than it used to be.
Yes. So yeah, that's true. That it's way easier than it used to be, and that it actually saves you a lot of time, maybe even money, and like you don't need to invest in the tools as well, as you mentioned
Exactly.
before. However, we have noticed that the 3D printing process is generally very slow, and that even for printing like something very small, it can take up to several hours. So I would like to know, Philip, is it because of a hardware limitation, or is it because the software is not that fast? Or what is needed to improve the performance of these machines?
It doesn't have something to do with software. That is not a part of the issue here. One issue is that we have some physical limitations. For example, if we talk about FDM printer, which a lot of people might relate, you have a nozzle, a head that moves around in X, Y, Z, and you have in order to be very precise, like you want your parts, your objects to be precise. If I
Yes.
say it has to be 20 millimeters long, then you want it to be 20 millimeters long. The
So,
thing is, if you move something very fast and it has to stop at a specific point, you cannot, like, you have to have a very, very sophisticated mechanical system to make it stop at this specific point.
yeah.
It is possible to do that very fast, but that is not the only thing you have going on at that moment, that you have a mass that you accelerate and then you have to stop it, so negative acceleration. That is one challenge. But then in addition, you have hot plastic coming out of this thing at the same time that has to solidify also. So you have to cool it.
Yes.
Like you first have to heat it, then you have to cool it so it solidifies at the right moment, at the right position.
Wow.
And this is one of the, let's say, more easy systems there is. If you imagine you have a powder where you shoot a laser into that moves with several thousand millimeters per second, it gets more and more complicated. So we have this physical barrier that most of the times we melt, or like we have this physical process of fusion, of binding the materials together, and that just takes time. You can speed it up, but there's still some limitation. So the other thing is that from just the idea is that we do it layer by layer. Like in injection molding for plastics, for example, we also melt the plastic and it solidifies in the form, but
Yes.
the whole part at one time does it. But now with additive manufacturing, we do it layer by layer. So we just need more time because each layer has to be heated up and each layer has to cool down. We're not doing it at the same time. So there's some limitations that we cannot take away. But saying that, we're not at the end yet. Like we're not there yet. Like those limitations, we still have some room to grow and to speed it up. One example is that we not only use one laser that works on the same time, but we use multiple lasers that work on the same time. So like that, I can easily double or triple or whatever increase the speed. Just some months ago, a company introduced a system with 12 lasers that work at the same time.
Wow.
And you can do the same with the printing heads or something else. So there's still a lot of room to grow, and it actually happens. So this whole area of industrial 3D printing, I would say every year there's a new technology that pushes the boundaries even more. It's very, very dynamic, and it's very hard to keep track of because there's so much new things going on. And one of the major things is to increase the speed of the production, because that's what it's all about at the end. The faster we are, the less the parts will cost, and the better. But of course, we also need to do that, taking in consideration that I just don't, if it's 20 millimeters long, I want it to be 20 millimeters long, not 21, 22. It has to be 20. So that is the challenge. But a lot of bright people working on that, luckily.
Yeah, it sounds something very interesting. In my case, recently I was reading about something called 4D printing, but I didn't understand very well. Do you know something about this new area, or let's say the next boundary in 3D printing?
I know a little bit about it. As you said, it is the next boundary, I would say. The 4D means that we add another dimension, so 3 dimension, right? X, Y, Z, all the dimensions and space.
Yes.
4D would be to add a fourth dimension, which would be time. So the idea behind the 4D printing is that we produce materials and objects that change their property within time. And that gives us another dimension and freedom and to do things. So let's say you would 3D print a geometry in the printer, and then you put it into its environment where it has to operate, where it has to function. And there, based on, let's say, the temperature, the pressure, the humidity, or some kind of property, this object changes because we submit it to this area, or just because of time, it changes. So 4D printing is basically combining two areas of research and development, which is 3D printing and smart materials. And those are being combined to 4D printing. But it's still very, very early. I'm not aware of any industrial application of that yet.
Okay. So yeah, I was about to ask you that very same thing, that if you knew about any applications, because it sounds something very, I don't know, I cannot come up with something that it can be used for in real life right now.
One possible application, as so often in 3D printing, comes from the medical area. One area where we already use some kind of smart material is stents. I don't know if you're familiar with the concept of stents. It is for heart diseases, where you introduce, let's say, wire that into your arteries or your I'm not a medical expert, but I don't know if it's arteries or I just get a thumbs up. That's arteries.
Yes.
Into your arteries, and there the stent expands in order to keep it open, so the blood flow is guaranteed.
Okay, yeah.
That is what happens if you get a heart disease or something like that. Your arteries close and you need to keep them open again.
Yes.
So what is done there already now is that you have a material that is very small, like it's folded together, this stent made of wire, and you implant it into your body, and there it expands, because it's much easier to implement something small into your system, and then it expands.
Yes.
And currently those things, those stents are manufactured with traditional manufacturing processes. But one idea might be that we use 3D printing to do it, to come up with better geometries, for example. Other things might be in, I don't know, space applications where we wanted to, where we have issues with very harsh environments, where you basically, for example, cannot use electric circuits or something like that, and you need an actuator, that like a thing that moves and changes something. And you could use smart materials for that. And yeah, there's some high-tech applications possible, but like I said, it's still there's something in the future where there's a lot of research necessary.
Yeah, and I'm wondering about, let's say, still about this topic. Do you think that, because as you said, harsh environments, do you think that we could use, let's say, maybe in 10, 15 years, the 4D printing to build some parts that can be sent to Mars, or how to adapt to that very harsh environment? Because people try to colonize Mars, and well, we have nothing there to test.
Yeah, that might be one possible application for the 4D printing, but also for, let's say, 3D printing. And like one idea I'm aware of is that, for example, when you want to do something like space exploration or colonizing Mars or something like that, you have to shoot stuff up into space. And in order to do that, like the lightweight design is very, very important in that area, in that space, because every gram, every kilogram you shoot up, you need fuel to shoot it up, and it's very expensive to do so. The funny thing is that most of the things that we have, for example, on space stations or something like that, are over-engineered. They're way too heavy. They're way too big, because they have to withstand the launch of into space. Then in space, there's not much mechanical loads that have those things, right? They're in zero gravity environment. So one idea is that we only shoot up the material into space and 3D print it in space. Like that, we can actually design and manufacture the things for the requirements they have. Right now, most of them are just over-engineered because they have to withstand the high acceleration forces during the launch.
Yes.
After that, they don't have that many or big mechanical things or mechanical loads anymore. So yeah, that's something I know NASA is working on. I think there is already 3D printers in the ISS. I have to think
Nice.
about that. There has been developments to do that, to investigate it. I don't know if they have been deployed yet.
Okay.
But this is definitely something that is out there and coming. And yeah, I mean, 3D printing is already used in, let's say, everything else about space exploration. Like there is 3D printed parts in engines, there's 3D printed parts in the structural components of a rocket. So there's lots of applications there.
I can see that we went a little bit further into the interview and we're already talking about the future. But I would like to come back to the present.
Yeah, sure.
And talk about what you mentioned, that nowadays, even nowadays, 3D printing is being used in several industries.
Yes.
And there are also some people that already have their own 3D printer at home. But there's one special industry that I would like to discuss with you, Philip. That is the weapons industry. This is a very controversial topic because if you have one at home and you have the ability to create a design, then that means that you could actually print your own weapons, your own pistols. Do you think that, well, first of all, do you think that this should be regulated? And second, if it should, how? What are your thoughts on this?
Yeah, so first of all, yes, it's technically it's possible to 3D print your own weapons. There has been quite a lot of videos and controversy about it. I think it is very hard to regulate. There is the thing with 3D printing is it puts the ability or the possibility to a lot of more hands than manufacturing has been traditionally.
Yes.
So if, for example, if a technician that learns it in school or whatever, like a CNC technician, and he comes up with the idea to get a CNC controlled machining center at home, he also has the ability to create weapons, but it takes a lot of more knowledge and capital to do that. With the 3D printer, you don't need that much knowledge, and you don't need that much investment to do that. So it's not a generally new idea, but it gives it a bigger access to a lot of more people. If we could regulate it, yes, I think we should. I don't see a way to do it because it's very hard. Every 3D printer should have a code written. It's like some, I don't know, software, something built inside that prevents it from printing the weapon. It would have to automatically identify something as a weapon and then prevent it from being printed. But the thing is, yeah, there's this saying like everything operated wrongly can be a weapon or yeah. Right. So where is this line we draw in saying, okay, this is a weapon, this is not a weapon? That is very hard to draw. There is, if we look in normal two-dimensional printing, there is something very similar, but with money. Like you cannot print money with your home printer, or physically it could print it, But there is algorithms that somehow, maybe you know more about that than I do, but somehow detect this is the bill that you want to print. And there it's very easy because the bill is something regulated. There is probably some visual code put in there where the algorithm can detect it. With
Yes.
weapons, it's very hard. Like I don't know how we could do that. Like there had to be a very, very sophisticated AI to figure out this could be used as a weapon and this shouldn't be used as a weapon. So it's a very controversial topic.
Yeah.
Honestly, I don't have a solution for that. It's I mean, it falls under legislation that you're not allowed to those are firearms, for example. When we talk about weapons, we're mostly talking about firearms here.
Yes.
So it is in some way, it is legislated that in most of the countries I know, there is legislation for owning and carrying firearms and weapons. So without any definition on how they're manufactured. But like I said, it just opens up the possibility to a lot of more people. But yeah, you have me there in a weird spot because I don't know a solution for that. It's a very hard topic.
Yeah, it's a complicated topic to deal with. But maybe let's try to move to a more fun part. Let's suppose that I am a new person. Like, for example, you had experience going to the school, to the university to learn these important skills. But let's suppose that I have no education and I'm interested into developing, I don't know, let's say my own bottles, or let's say start selling something at home. Let's say, how can I learn about it?
So it is actually quite easy to pick it up, I would say. There is a lot of information, a lot of communities out there that can help you figuring out what to buy, what to do, what to start, or where to start. One thing that you always have to take into account is that as definition for 3D printing, you need a 3D model. So you have two options there. You can create your own 3D models, or you can look in the internet for already existing 3D models. There is big databases of people uploading their files and their geometries. One of them is, for example, Thingiverse, where you can basically just look for things and people upload their geometries. But I would say that is only half the fun of 3D printing. The thing is that you can create your ideas, your concepts. So the first thing you should start is learning about CAD, so computer-aided design. There is, if you're lucky and you're a student, then you can get a lot of licenses for lower money or less money or even for free. For everybody else who already graduated, there is two ways. You look for open source and freeware software, or you go and buy some of the software tools I mentioned earlier. The open source ones, to be honest, they're good, but not that intuitive, so very hard to use. You have to learn more. Of course, the ones you pay for, they're much easier to use, much easier to start with. And then there's also a lot of tutorials when and how to operate those software to create the CAD file. If you basically covered that, and I mean that can happen at the same time as you buy the printer and start printing. Like I said, there's a lot of communities online and forums that you can look for advice and basically each 3D printer manufacturer or brand has its own support forums and platforms where you can learn about using your 3D printer at home. There's also some nice books already out there that can explain you how to do it. On a, let's say, general idea, like on a more systematic or general approach, but there's a ton of information online available, and just pick one printer and start running, I would say.
That's pretty cool. It sounds like, as in programming, that you can just pick up something from the internet and start learning from it.
Yes.
However, if we would like to, let's say that we would like to move forward and we would like to work professionally on it, do you think that in order to get a job, college degree will be necessary?
Maybe in the future. Right now, the funny thing is I'm not aware that there is a college degree for additive manufacturing or 3D printing. Like it is part of some of the curriculums of let's say mechanical engineering, maybe mechatronics or something like that. But there it's not a single program. Let's say you cannot study 3D printing. There is some additional qualification. We have, for example, a program in Germany from the Association of German Engineers. That is a association here in Germany where you can do a several-day-long course, and then you can call yourself an additive manufacturing engineer, for example. That is available. I'm pretty sure that it's available in other areas in the world as well. But it always it depends on what you want to do. Of course, if you want to work in the area of designing and for example, what I do, looking for applications, a college degree helps. Like a university degree helps, and engineering, mechanical engineering, so you understand the basics of manufacturing. If you want to work and operate machines, be a machine operator, there's also some qualification you need for that. But of course, for that, you don't need a college degree to operate a 3D printer. It's just another piece of machinery than all the other manufacturing machines we already know and have around the world.
Now let's move to the final part that is about to do the predictions about the future of what you visualize, Philip. My first question is, do you think that in the next 5 years, we are going to be able to produce, let's say, large pieces like for the rockets that Elon Musk is sending, or let's say Amazon to the space, or is it something that it's gonna take a little bit more of time?
I really like that question because there is already the future is already now. There is already parts in the SpaceX rocket that is 3D printed. One of the main components of the engine is actually 3D printed and goes to space. One of the major applications in 3D printing was the fuel injection nozzle for planes in plane engines. So of course there will be larger parts. I guess there will be more applications. There's those are single unique applications. I think in the next years we will see more and more of them. But what I think, or what I will look out, is not so much more applications in the high-tech area, but also in the low-tech area. So with increased production speeds, with lower costs and more knowledge available, I think we will start seeing 3D printed parts more and more in our day-to-day life. It started with consumer goods, like Adidas was 3D printing shoes. There is some 3D printed glasses you can wear, and I think we will see more and more of that in the future, to mass customization, so that we have products that are unique to each individual customer. Like I said, they started doing that, but I think in the next years we will see more of that with the increased possibilities that we'll have in the future.
That is pretty amazing to know that even SpaceX is using nowadays 3D printed parts. And my second question about the future is regarding housing. You mentioned at the beginning of the interview that there have been already some applications and some houses printed. Do you think that in the future, in the near future, let's say, it will become more of a common practice to 3D print houses and buildings, like for people?
I think that is something that just started, and there has been some pilot projects of houses and companies doing this. But I think that is something we also will see more and more often, because it deals with one very specific area of construction sites and building houses, you need skilled labor to do that. Like you need people who are able and know how to build a house. And this is also, again, very controversy, I would say, with automation, but with the 3D printing, we could automate a lot of those processes of construction sites and building, which on one hand is nice because it makes it faster, cheaper, and so on. But on the other hand, we're talking about people's jobs that are there at risk. But I'm pretty sure that we will have other jobs evolve out of this. And I'm pretty sure that, yeah, we will see 3D printed, maybe not directly houses, but structures a lot more in the future. And then sooner or later, houses as well.
Thank you very much for all your thoughts, Philip. Hopefully more people can join maybe in your area developing these skills. And hey, I will say that 3D printing is more interesting than I ever imagined, and I never visualized that the SpaceX is doing these experiments. Any final thoughts that you would like to add, Philip?
Yeah, I think, like I said, it's a fun thing to pick up, to do it at home, 3D printing. It gives you a lot of possibilities to expand creativity and produce your own things at home. That's a lot of fun, and I can encourage everybody to try and yeah, give it a shot. And yeah, again, I'm very, very thankful for you inviting me today. It was fun talking about 3D printing with you. And I hope I could explain, yeah, most of the things correctly. If I here and there made a mistake because of oversimplification, I apologize. But yeah, I'm looking forward to maybe next time or other times. I will definitely check out your podcast as well.
Thank you very much, Philip. And until the next time, bye-bye.
Thank you. Goodbye.